The B Series. Honda's gift that just keeps on giving. While engines from the established car manufacturers shared some of its excellent traits, Honda always had a trick up its sleeve, and it was called VTEC. It gave the B Series the best of both worlds, a smooth idle and efficiency, and when activated, it used a cam profile similar to a race-prepped engine, allowing it to rev to astronomical levels and make power unlike any other economy-based engine before it. And best of all, it was the everyman's engine. Anybody could afford it. It wasn't too complicated to build, and combined with the turbocharger, it can make all the power you could ever dream of. This is the story of arguably the greatest inline four-cylinder of all time, an engine that helped transition Honda from being known as just an economy car manufacturer with some cool motorcycles to a preferred platform to build, to race, to break, and then to rebuild again. This is the story of the mighty Honda B Series. "100 horsepower per liter. For a naturally aspirated engine, that is the measuring stick to consider an engine regardless of configuration and displacement as a true performer. By today's standards, this number and beyond is fairly commonplace amongst exotics and even Ford Mustangs like the GT350. But in the late 80s, to achieve such power density meant you had to prioritize ungodly revolutions over rationality. In 1987, Honda had a humble little sport bike called the CBR 250R. It was an exercise in how high a production engine could rev and still stay in one piece. With its 250cc dual overhead cam inline four-cylinder engine that used a gear-driven valve train, it could rev to a red line of 17,000 RPM from the factory. That is 283 revolutions per second. From a power density perspective, it was pushing the equivalent to 180 horsepower per liter naturally aspirated in 1987. A true marvel of Japanese engineering for the time, especially for what many would consider an entry-level sport bike. That high RPM mantra was prevalent in their sport bikes, but not in their passenger cars. That was until the engineer Ikuo Kajitani, working for Honda's Tochigi Research and Development Center, proposed the idea of making 100 horsepower per liter engines available across Honda's passenger car lineup. And to achieve this, a project was proposed to look into variable valve timing as a way to solve a century-old problem of internal combustion engines only being correct in one area. The size of the valves, the camshaft duration and lift, intake port design and length all come together in harmony at one point in the RPM range, where peak torque is made, which is also where the engine is its most volumetrically efficient. Kajitani's idea was to make the engine efficient in two spots, by changing the camshaft profile on demand to create low RPM and high RPM efficiency zones, therefore giving it a broader range that was not possible with a single camshaft profile. The mechanism to actuate the switching of camshaft profiles proposed by Kajitani used a set of 3 cam lobes and rocker arms, 2 for efficiency and 1 with a race profile cam lobe. At low engine speeds, the 2 outer cams were used to open and close the valves, with the center cam inactive. However, as RPMs increased, the engine computer signaled the spool valve to direct oil pressure to activate a pin. This forced the 2 outer arms to act upon the center arm, which used a racing cam profile optimized for high-end horsepower. It was absolutely genius, and it was no easy task to engineer. Kajitani in his own words said, "I thought we might not be able to achieve it because the goal was too high, but in the end, it was a success." A task of this magnitude, like bringing racing technology into compact economy cars, or even tasks of just making it through the daily grind, can create immense pressure on an individual, and our upbringing and generational beliefs can stop us from seeking help with our internal struggles. Mental health isn't discussed in every home, and sometimes you are just told to just get over it or just bottle it up. Well, you don't have to, thanks to our sponsor, BetterHelp. Therapists listen, they ask questions, and they help you see things from a different viewpoint, which can make a world of difference for your mental health. If you think you can benefit from speaking with a licensed therapist, click the link in the description and go to betterhelp.com/337speed to match with a therapist, and using my link also gets you 10% off your first month of therapy. You don't have to do this alone, and regardless of our upbringing, we can all use a little bit of therapy. This revolutionary form of variable valve timing was called VTEC, short for Variable Valve Timing and Lift Engine Control. The B16A launched in the 1989 Honda Integra XSI, in the Civic and the CRX. It was instantly a hit amongst enthusiasts, and eventually started an arms race for other manufacturers to develop their own proprietary variable valve timing systems, most notably Mitsubishi, with their MyVEC, or Mitsubishi Innovative Valve Timing Engine Control System. MyVEC used an arguably more complicated method using a T-lever that in the low-speed operation struck nothing but air, but as oil pressure increased with RPM, the piston inside the rocker arm would move upward and the T-lever would contact the pistons in the rocker arm, allowing for more lift. It was just as genius as VTEC, but 4 years later than the B16A, and it was obvious what inspired it. The B series came in an assortment of flavors with 5 different displacements: the original B16A and A1 through 6, the power-dense B16B found in the JDM EK9 Civic Type R, the B17A1 found in the Integra GSR, the B18A and B found in non-VTEC Integras, the record-holding power per liter B18C and C5 found in the Integra Type R that was capable of 9,000 RPM out of the box, and the torquey B20 engines found in CRVs. They all were in large part interchangeable, so taking a cheaper non-VTEC B18B short block from an Integra LS that only originally supported 6,800 RPM power and transplanting it with a B16A VTEC cylinder head that flowed more CFM of airflow created a torqueier version of the B16A with the same high RPM power band. Quickly, the B series would become one of the most revered engines to modify. Companies like Spoon Sports took the B16B from the EK9 Civic Type R and stroked it from 1.6 liters to 1.8 liters, added more aggressive camshafts and stiffer valve springs, individual throttle bodies, and ECU tweaks to make 260 horsepower out of a 1.8 liter naturally aspirated engine, and it revved to 11,000 RPM. The B series was a powerhouse when turbocharging was applied. Since the VTEC system already had a race cam profile baked into it from the factory, it didn't need a cam swap to take advantage of the added airflow from forced induction. Therefore, once boost was applied, reaching 500 horsepower or more was a relatively easy task to achieve with a forged rotating assembly. If money is no concern, the B series has seen over 2,300 horsepower in drag racing spec, crossing the quarter mile in 6.6 seconds at nearly 200 miles per hour. The B series began to be phased out in the early 2000s for Honda's new K architecture. The K series didn't use a distributor, rather coil-on-plug ignition, a timing chain versus a timing belt, and VTEC was upgraded to iVTEC that advanced the intake cam timing at the low to mid-range to fortified torque, rather than top-end power. The K-Series also was just like the B-Series in the sense of Frankenstein builds. So a K24A2 short block from a Acura TSX with a K20A2 cylinder head from an RSX Type S is a budget-friendly option that, when boost is applied, can make 550 to 600 horsepower fairly easily, much easier than the B-Series before it. In today's economy, the K-Series is the go-to option, as B-Series engines have exploded in price as they are getting much harder to find in decent condition, and just give it up if you're trying to find a B18C or C5 to swap into your project car. While the B-Series was here for a good time and not a long time, it pushed the envelope of what was achievable with such little displacement. Not only did Honda use its VTEC technology in the C38 Power NSX, but it used it across the whole engine lineup because there's just something special about having turbo lag without the turbo. All jokes aside, the commercial and aftermarket success of the B-Series engine pushed the industry as a whole to make variable valve timing and lift a necessity to be competitive. Mitsubishi's Maivec and Nissan's VVL all can trace its conceptual roots to Ikkyo Kajitani's revolutionary idea of changing the cam profiles on the fly. Today, the K-Series carries the torch of making lots of power in a small package. But it's important to remember the engine that started it all, the B.